question number 1 from the 2022 paper. It says, find the speed of P at time t equals 2 seconds. And it's given us V. What's V? V is the velocity, right? Now, if you remember, from velocity, we can get to speed by taking the magnitude, isn't it? Because speed is a magnitude. But because the rest of this question will ask other things, for example, acceleration here and the position vector, I'm just going to quickly remind you of this. How do you get from velocity to acceleration, for example? How do you go from displacement S or R, whichever one you want to use for that, it's not a problem, to velocity? So what do we do? To get velocity from displacement, we differentiate. Yeah, so it's going to be ds over dt. And to get from velocity to acceleration, we differentiate velocity, so dv over dt. And going up is to integrate. Yeah, so if you go from acceleration to velocity, you integrate a, so it's a with respect to t. And if you want to get to displacement from v, you also integrate. So it's going to be the integration of v with respect to t. All right. But for this question, we're just finding the speed, which is the magnitude of that. Okay. So what will I do? I will sub in the value of t equals 2 into my formula, and I'll find my velocity in terms of I and j. Okay. So that would be v is equal to 3 bracket 2 for t squared, that's my I, minus 6 times 2 to the power of a half. Okay, and that's my j. So, what do we get? 2 squared, 4 times 3, 12. So that's going to be 12i. 2 to the power of a half is square root of 2, and times that by 6. So that's going to be minus 6 root 2j. And that is meters per second in i's and j's. But it's asked us for the speed. So the speed will be the magnitude of v. Okay, how do we do that? We do a square root of 12 squared plus minus 6 root 2 squared, and we work that out. And that gives us the square root of 216, which is 14.7 meters per second. All right, now, if we go on to part B, it says find an expression in terms of t, I and j for the acceleration of p at time t seconds, where t is greater than 0. So if we look back at this, we said that if you want to find acceleration and you've been given v here, you differentiate. Okay, you differentiate. So we're going to differentiate that, and we're going to differentiate it in that form. So let's write that down. So a is going to be found by the differentiation of v with respect to t. So that, therefore, that will be a is equal to, and now we're going to differentiate that. So that's going to be what? We bring down the power. So it's 3t squared at the moment. So we bring down the power, which is 6ti. And then on the second one, we bring down the half, the 6, we multiply. That gives us 3. So it's going to be minus 3t to the power of minus 1 over 2j. Okay, so that's your acceleration in terms of i's and j's. Okay, that's your expression done. Now, what does it say? At time t equals 4 seconds, the position vector of p is that. So now, what's it talking about when it's talking about position vector? It's talking about the s, the displacement, right? So we need an expression for displacement. And we are going to find what the displacement is at, t equals 1 second. When do we use that? That's going to be used when we integrate v, because we're going to use v to find our s. When we integrate v, we're going to have a constant, okay, a plus c. And that is how we're going to use the value of t right there, okay? So for part C, first let's find our expression. So s is going to be the integration of v dt. So the integration of 3t squared I minus 6t to the power of a half j respect to t. So let's go ahead and integrate that. So we add to the power, so it's going to be t cubed. So s is going to be equal to t cubed over 3, which is that. Now, and the 3 is there. I forgot to do that. That cancels though, yeah? That's what I was getting at. That cancels. So it's going to be t cubed. And then this, we add 1 to that power, so it becomes 3 over 2. And then we're going to do 6 divided by 3 over 2. Again, that simplifies. That simplifies 2. 6 divided by 3 over 2, so times by the 2, that's going to be 12. divided by 3, which is 4, yeah? So it's minus 4t to the power of 3 over 2. And then your plus c, and that's your s. Yeah? Now, I said to you earlier that we're going to use that value of t equals 4 to find our c, our constant, okay? And also that we know the position vector, the s value, is I minus 4j at t equals 4. So we're also going to use that as well. So we know that the position vector, PV, let's call it, is equal to, what was it equal to? I forgot now. I minus 4j at t equals 4. So therefore, let's sub that in. So I minus 4j is equal to 4 to the power of 3 plus, oh, I forgot to do the i's and j's, I and j. So 4 to the power of 3i, plus, not plus either, minus, right, minus 4 times 4 to the power of 3 over 2j plus c. So if we work this out on our calculators, so 4 to the power of 3, that gives us 64i, and the next part of that gives us 32j plus c. And then if we rearrange this in terms of making c the subject, so take the I to the other side, take the j to the other side, and therefore you have c is equal to minus 63i plus 28j. So that's your value of c. Now you can just go and replace it right there. Okay, you can replace your c right there. So the full and final version for s, an expression for the displacement, the position vector at any time t, is t to the power of 3i minus 4t to the power of 3 over 2j minus 63i plus 28j. Okay, now of course you could pair them up as well. So you know the i's and the j's, you put them together. So you could have s is equal to, so you can put the t cubed and the 63 together because they are both i's. Okay, so that would become t cubed minus 63i in a bracket plus, we're going to start with a positive on the j's because we want to start, I like starting with the positive, but it doesn't matter. And so it's going to be 28 minus 4t. Okay, so it's going to be 28 minus 4t to the power of 3 over 2j. So that's your position vector at any time you want it. When do you want it? For. If you look back at the question, it says find the position vector at time t equals 1 second. So you're going to sub in, t equals 1. So s is going to be 1 cubed minus 63 for the I, plus 28 minus 4 times 1 to the power of 3 over 2 for the j. And if we work that out, we get minus 62i plus 24j. And that's meters, okay? And that's your answer. All right, so let's look at this one. Question 2, a rough plane is inclined to the horizontal at an angle alpha, where our tan alpha is equal to 3 over 4. A small block B of mass 5 kilograms is held in equilibrium. I'm going to start highlighting stuff. Okay, equilibrium here, we've got the tan right there, we've got the rough plane, that's important for me. And then we've got a horizontal force of magnitude x newtons, which is there in the diagram, so I won't highlight that. The force acts in a vertical plane, which contains a line of greatest slope of the inclined plane. The block B is modeled as a particle. The magnitude of the normal reaction of the plane is 68.6, which means, if we can do that right now. So for B, the magnitude of the normal reaction of the plane on B is this. So usually with these diagrams, you're going to write down R, okay, but here you're given what R is, okay? You're told that R is equal to 68.6 newtons, okay? So, but usually that's not given to you if you look at previous past papers, okay? Right, now with these questions, guys, it's always following the same sort of pattern. The first thing is you need to annotate your diagram and make sure you don't leave any forces out, any components that forces need out either, okay? So let's just go in here, zoom in a little bit and do that for our diagram before we read what part A and part B does, because whatever the question is, this needs to be done regardless, all right? So you need to get really smart doing this, guys, okay? So here, this is the weight for the particle. We are told that it has a mass of 5 kilograms with gravity, F equals ma. So force is equal to mass times acceleration. Mass times acceleration. Acceleration here is gravity. So it's going to be 5g, okay? 5 kilograms times gravity, 5g. Then what I normally do is I do this dotted line thing, which are the components of that, okay? So this angle right here, let me zoom in here. See that angle right there? That is alpha. This angle and that angle are always the same. Okay, that's alpha. Okay, and we're going to look at this later through this tan thing. Okay, we're going to do that in a second. We're going to draw a triangle. If we look at the x force now, okay, we've got this x force. Again, that needs components like that. Okay, so using a different color, I'll do that too. That one is going to be going down and across towards the right like that. This angle right there is going to be the same as our alpha as well. Okay, so if you're wondering how these angles are alpha or why the angles are alpha, then I suggest you go back to the basics of drawing these diagrams. Okay, now what else do we know? We know that the plane is rough. That means if this particle is being pushed up by this force, you're going to have friction working against it. So you're going to have friction coming down like that, right? So friction, let's add this. That's going to be FR. We'll call friction FR. All right, is that good? So that's your diagram done more or less. Now I said we're going to look at the tan alpha thing. So if we look at the tan alpha, that requires us to just quickly draw a diagram, and tan is opposite over adjacent. So opposite side is going to be 3 and adjacent is going to be 4. So to work this side out using Pythagoras' theorem, we should know the Pythagorean triples, but that's going to be 5. Yeah. So we can work out sine alpha and cos alpha now, which we will generate from when we do our F equals ma and all of that for part A. Okay. So what sine alpha is opposite over hypotenuse? Opposite is 3 over 5. And then cos is going to be 4 over 5. So that's that. Okay. So if we now I'll just make a copy of this diagram because I'm going to be needing it later. So the first part of the question says, find the magnitude of the frictional force acting on B. So in other words, find X. That's what he's asking us to do. And then state the direction of the frictional force acting on B. So the direction of that. Okay. Sorry, have I got that right? No. Sorry. Let's read that again. So the first part of the question says, find the magnitude of the frictional force acting on B. So find out what this F friction is, FR. Okay, and second part says state the direction of the frictional force acting on B. So look, I've done it like this, going down. Okay, it could be that it's going up, meaning this is maybe slipping down because X isn't giving it enough force to keep it up. Okay, maybe it's actually starting to slip down, and therefore frictional force will be working against it that way. So we'll see anyway by taking a direction and sticking with it, and then resolving our forces. All right. So if we go ahead and do that down here, so I said I'm going to just paste the image right there. Okay, so here we go. I've pasted the image. So the first thing what I want to do is set up some forces. So if I go, let's say this way as a positive. Okay, so this is my positive direction. For that, I'm going to resolve that way, and I'm also going to resolve, let's say, going down like that. Okay, later on. Okay, so what do we have in that direction? How many forces do we have in that direction? We've got one here, one there, and one there. Okay, so we are not going to be including F of R in this direction. Okay, we're only going to be including this one, and that one, because that is in this direction. All right, so let's do this. What do we have? Let's start with R because we are going up as positive. Okay, so R is going up in that direction, whereas these ones are going down. Okay, this one is going down, okay, as negative. Okay, can you see that? That's why I've drawn these arrows here like that. So it's going to have R, and then how do you introduce X? What is this side? Okay, what is this side right here? That is opposite this, isn't it? So it's going to be sine. Okay, so it's going to be minus, because it's going the opposite direction to my positive. So it's going to be minus X sine alpha. And we've got sine alpha, okay, where we're going to substitute that later, okay, but for now let's just leave it. And then what else do we have? We have this one going down again, opposite this. So that's going to be minus again 5g, and then this is your angle, and this is adjacent to the angle, so we use cosine. Okay, so we use cos, so it's cos alpha, and this is going to be equal to what and why? It's going to be equal to 0 because the question said it's in equilibrium. It's not moving. Okay, it's doing nothing, just stationary, sitting there. All right, so that's that done. We can later on go in and rearrange it to do whatever we need to. But for now, if we just substitute those values in, that would be quite useful. So sine alpha, instead of sine alpha, we're going to use 3 over 5. And instead of cos alpha, we're going to use 4 over 5. Okay, let's quickly do that. So it's going to be r minus x bracket, and sine is 3 over 5, minus 5g bracket, cos is 4 over 5. That's equal to 0. Okay, so if we work this out, what we can do might be useful is maybe take all, well, what we're trying to find, the magnitude of the frictional force. Okay, that's f of r anyway. So f of r is not even involved at this stage. That's going to be coming in from something else, all right? But we are told the value of r. If you remember in the question, r is this. Okay, so we can sub that in as well. So let's get rid of that and sub that in. So 68.6. Now x is the only unknown because obviously g is 9.8. Okay, x is the only unknown. So we are going to make x a subject. Okay, might as well just find it. How do we do that, guys? Yeah, we first of all, x is negative here. So shall we take it over to this side and just make it positive right now? So we're going to have 68.6 minus, and also here, look, the 5 and the 5 here cancel. So we can just have 4 times g. What's 4 times g? If you calculate that for me, that's going to be 39.2. Okay, there, that's all done. And on the other side, we take the x over to the other side. Now, 3 over 5 is 0.6. So it's going to be 0.6x. Now, we just take these away, as it says to do, and then divide by 0.6, and we've got x. So x will be equal to 49 newtons. We've got x. But we were asked to find the frictional force, which is F of R. All right? So in order to find F of R, we are going to take, or resolve rather, we're going to resolve going down the plane. Okay, we can go any way we want, but I prefer to go down the plane because it's as though this thing will be moving down the plane. So I've just chosen this to go down, all right? You could choose to do going up as well. Okay, but this is a personal preference I have, which is to just go down the plane. Okay, direction of motion. Okay, if there were no forces there, what would happen to the particle? It would go down the plane. That's it. All right, no other reason. So again, what do we have in that direction? We have this, we have that. Well, see in here, guys, be careful here. We've got 2 forces here, okay? One of them belonging to the x going up, so the arrow is that way, and the other one belonging to the 5g, which is in pink, going down that way, okay? So just bear that in mind, we've got 2 forces. So in total, 1, 2, and 3, okay? 3 forces. So because f of r is positive, I'm just going to keep that positive, so positive f of r. What else is positive is the 5g's pink one that's going down the plane. So it's going to be plus 5g, and this 5g's this side here is opposite, so it's going to be sine. So it's going to be 5g sine alpha. Okay, again we're going to use that 3 over 5 for sine alpha. And then for the xn, it's going to be negative because it's going against my direction of the arrow. Okay, so it's going to be negative. And we know xn now, don't we? Xn is 49. So from earlier on, I'll do that in another color though. So xn is 49. So this side here is going to be cos alpha. So it's going to be 49 cos alpha. And that is also going to be equal to 0, because it's in equilibrium. Okay? Now, f of r can now be found by taking everything over to the other side after you've substituted those values in, or you can do it on the other side as well. Okay, in fact, let's do that on the other side. So we're going to start with positive because this will become a positive on the other side, whilst this will become a negative. So we'll do the positive version. So we'll have 49 cos alpha. Cos alpha was 4 over 5. Yeah, 4 over 5. So 4 over 5, and then minus 5g sine, which was 3 over 5. There you go. So if we work this out, we'll get our answer. Once again, these cancel, so you just need to do that, but you can put that all into your calculator. So the friction is 9.8 newtons. Okay, that's your friction. That's the magnitude of your frictional force acting on B. Now, what about the direction? Okay, the question talked about the direction. Well, look at this. In our diagram, we've made the friction going down. We obtained a positive value for our friction by going down as positive. What does that show? That indicates that we are correct to show the friction going down because the frictional force is going down the plane. Okay, so it's going down the plane. All right, so that's 4 marks. The horizontal force. Now you might be wondering, by the way, before I continue, like, whoa, look at all this working out I did for 4 marks. You know, the diagram in the old spec A level, they used to give you a separate mark, or marks, I should say, just for annotating that diagram. So this is actually part of your working out. All right, it's not just, you know, that the 6 marks that you see here, it's not just doing that part right now. You've already obtained a lot of the marks, okay, for that. But the question is, can you continue doing it? All right, what does it say? It says the horizontal force of magnitude x newton is now removed and B moves down the plane. Okay, so that means this force is no longer there. All right, what happens if this is no longer there? Let's draw a diagram. Okay, find the acceleration of B down the plane, and we also told that the coefficient of friction is 0.5. Okay, let's draw a diagram where we have a situation where x is removed. All right, so what does that look like? So let's just draw this in. Okay, so this is what we have. So if I'm not doing anything else here, because we're going to talk, oh yeah, we've got the mu. Okay, I've done nothing else, yeah? Now, naturally, guys, this particle on a slope, what would it want to do? Well, what's it going to do? It's going to go down the plane. Now, the plane is still the same plane, which was rough, which means the friction, if this is trying to go down the plane, friction is going to be going the opposite way, up the plane. So the first thing we can add to our diagram, which has changed, is frictional force is the other way. All right? Secondly, in the old situation, the R value was 68.6 given to us. Is it still the case that the R value would be 68.6? No. The reaction force will change. So that's going to be R, unknown. All right? That's it. This is your diagram. Let's go and put those components in for what requires a component. And just as a reminder, what requires a component is when you don't have anything going along the plane or perpendicular to the plane. Okay? Because that's how we resolve. So this one is going to need components. Okay? So let's just give this one its components right there. This is alpha. All right, let's go ahead and resolve. What we're doing, by the way, we are finding acceleration. Okay, let's just add that acceleration as well. It's going to be going down the plane. We are looking for A. Yeah, unknown. Okay, right, so let's go resolve first. So let's start with this way, going down the plane. Like I said, naturally, I go down the plane. So what do we have? We have this one right there. Yeah, we have this one right there. So it's going to be 5g sine alpha, which again will replace, minus f of r, yeah, is equal to, now this time it's not going to be equal to 0. We're going to be using F equals ma. Force is equal to mass times acceleration, because with the force of motion, it's moving. Right? This thing is moving. Now, what's the mass of the particle? 5. The acceleration, I don't know. We're trying to find it. Okay? So let's go replace the stuff now, like sine alpha. So it's going to be 5g. Sine alpha was, what was it? 3 over 5? 3 over 5. So it's going to be 3 over 5 minus the friction equals 5a. So we can cancel out the 5s right there. So we get 3g minus f of r is equal to 5a. Okay, you can work out 3g as well. So you can have that as, in fact, let's make f of r the subject. So f of r, we're going to take to the other side. So we're going to have 3g minus 5a. So 3g is 29.4, and then minus the 5a. We'll leave it like that. Okay, so just box that around. Now, we resolve going up like that. What do we have? We have 1, 2 forces. Okay, so it's going to be r minus 5g. Again, that's going to be cos alpha. Now, do we have a equal ma here? I mean, we do have an equal ma, but is it equal to 0 or is it equal to mass times acceleration? Well, this thing is moving this way. It's not, there's no movement in that direction. So it's going to be 0 still. Okay, that's going to be 0. There's no movement in that direction. So you're going to have r is equal to 5g. Again, cos is what? 4 over 5. 5's cancel. So it's going to be r is equal to 4g. Okay, 4g is 9.8 times 5. No, sorry, 9.8 times 4. So that's 39.2 newtons. There you go. We've got value for R. Now, what's the link? The link is to use the friction formula, which is F of R is equal to mu times reaction force. We know the friction, coefficient of friction rather, is 0.5. R is 39.2. We know F of R is all of that, so we can write that in there. So 29.4 minus 5a. Now can you see acceleration is the only unknown. So a is what we are going to go and find. So if you rearrange this, you should get acceleration is equal to 1.96 meters per second. And that is your acceleration. All right, guys. So for question number 3, a particle of mass 4 kilograms is at rest at the point A on a smooth horizontal plane. At time t equals 0, two forces F1, F2, where lambda and mu are constants, are applied to the particle P. Given that P moves in the direction of the vector free I plus J, show that this following. Okay. So when something is moving in that same direction of that vector, well, let's start here. Let's look at the resultant force first, okay? Because when it comes to I's and J's, working out the resultant force is very straightforward. So we are going to add F1 plus F2 to find our resultant force. So F1 is 4I minus J plus F2, which is lambda plus mu J. So if we add all the I's and the J's together, that's our resultant force. So resultant force, and that would be, so let's add 4 plus lambda, that's our I, plus mu minus 1, that's our J. Okay, so that's our resultant force, our expression. Now, if something moves in the direction of a vector that we are given, so in this case, the vector is 3I plus J, what does this mean? Okay, what does that mean? That means that our resultant force, so 4 plus lambda I plus mu minus 1 J is going to be equal to a multiple of that vector. So we can use, I don't know, let's use K. And it's going to be the multiple of that vector, which is 3I plus J. Now, if we multiply that out, so it's going to be 3K I plus KJ, and then we write this underneath again. It's the same thing. Okay. What does that mean? That means that this I is going to be equal to that I. And this J is going to be equal to that right there, that J. Okay. So we can set up some equations like this. Okay. So we can say 4 plus lambda is equal to 3K and mu minus 1 is equal to K. And if we work this out further, we can write an expression for K for the first one. We get 4 plus lambda over 3. And for the second one, we can have K is equal to mu minus 1, which is what it said, actually. We don't really need to do anything there. And then we can solve them. So we can substitute this right there, okay, and equate them really. So that gives us 4 plus lambda over 3 is equal to mu minus 1. And then what can I do here? I can have that formula right there, okay, by rearranging that. So let's multiply by 3 first. So if we multiply by 3, we get 4 plus lambda is equal to 3 mu minus 3. And then is that, what do they want? 3, okay, they want everything on one side. So what's positive? Okay, mu is negative. So everything needs to come from here onto that side right there, okay? So therefore, they're going to have lambda minus 3 mu, and then 4 plus 3 is going to give us our plus 7 equals 0, and that's our final answer. All right, what's next? Part B. At time t equals 4 seconds, P passes through the point B. Given that lambda is equal to 2, find the length of A to B. Okay, 5 marks. So, at t equals 4, given lambda equals 2, we want to find AB, the length AB. Okay, so the formula we've just worked out and it was given to us. So even if you didn't work this out in the exam, you can still continue the question and get the 5 marks by using this. All right, so lambda was 2, so that's going to be 2 minus 3 mu plus 7 equals 0. And then we can find mu from there. Can you see? We can rearrange everything. So take the 3 mu to the other side, and then 2 minus 7 is, sorry, 2 plus 7 is 9. And then mu again would be equal to 9 divided by 3, which is 3. So we've got our mu right there. So we can substitute both those values back into our, that resultant force thing that we had right there. Okay, so we can sub that in. So that's going to be 4 plus 2, that's your I, and 3 minus 1, your J. Okay, and that gives us 6I plus 2J. So that's our resultant force. Okay, let's quickly remind ourselves of what the question is, because sometimes you can get lost in what you're doing and need to go back. It happens to me. I need to continue doing that too. All right, so it says find the length of A to B. Right, at t equals 4 seconds, it's at the point B. All right, it's at the point B at t equals 4 seconds. So we are going to sub in for what? T equals 4 seconds into, hang on. We need a displacement formula, okay, to know where it is at t equals 4 seconds. Okay, because currently we can have a point A here and a point B there, right? And we want to find out that line, okay? But we don't know any position vector for B, okay? How does it get there? We know that we've got the resultant force, F, and we have a formula, force is equal to mass times acceleration, the force of motion formula. So using F equals ma, we can find acceleration because we've got the mass of the particle. Our force is 6I plus 2J is equal to mass of the particle, what was it? 4 times by A, our acceleration. So if we divide the other side by 4, we can have A. Our acceleration is going to be 1.5I plus 0.5J meters per second squared. Now, why did we find acceleration? If you go back to the first question that we did up here, right? If we have an expression for acceleration, we know that we integrate once to get V, integrate V to get our S, a displacement formula. So we now have found a expression for A, so we can integrate that twice to find our displacement formula. So going back to this, we are going to find S by integrating twice. Okay, so integrate A twice. Okay, so let's go ahead, and the first time we integrate, we are finding V. Okay, when we integrate. So when you integrate 1.5I plus 0.5J respect to T, you're finding D. Okay, so you're finding V. So that would be V is equal to, what's that going to give us? That gives us 1.5 Ti plus 0.5 Tj plus C. Now, we are also told, because we need to find the value of C, our constant every time. If we look back at the question, if you look at this, T equals 0 when it's at the position of A, where it starts off, yeah? When it starts off, T is equal to 0. So we can keep using that as our position, okay? So we can say that it's not moving, it's at rest at A. So we can say when V equals 0, T equals 0. So therefore, what do we have? We have 0 is equal to 1.5, 0I plus 0.5. I won't do this again if this is 0, 0, because it's just a waste of time. You know it's going to be 0 plus C. So C is equal to 0. So therefore, V is 1.5 Ti plus 0.5 Tj plus 0, which we don't need. Okay, that's V. What did I say we are going to do? We're going to integrate again. Okay, so this time to find S, we are going to integrate V. Okay, respect to T. So S will be equal to, let's integrate that. So it's going to be 1.5 T squared over 2I plus 0.5 T squared over 2J plus C. Okay, if we tidy up, so that gives us 0.75 T squared I plus 0.25 T squared J plus C. Again, we can use the same stuff. So at A, T equals 0, it hasn't moved, displacement is 0. So S is equal to 0. So therefore, it's going to be 0 in here, 0 for the t's, and like I said before, c is going to be 0 as well. So therefore the full and final formula for s is 0.75 t squared I plus 0.25 t squared j. Now, this is what I have. If you remember, the question is looking for the position vector or the position of point B, which is at t equals 4 seconds. So we can find that position right now by subbing in t equals 4. So at t equals 4, s is equal to 0.75 4 squared I plus 0.25 4 squared j. Okay, so s is equal to 12i plus 4j. Okay, that's it. Now, if we draw that diagram that I showed you earlier, A to B. So A, let's say, is the origin position. We know that to get to B, which is 12i plus 4j, is 12i there, 4j up. To find the distance of A to B, Pythagoras' theorem, so it's going to be 12 squared plus 4 squared square rooted. That's the distance of A to B, and that gives us 4 root 10 or 12.6 meters to 3 significant figures. Question 4, let me just zoom in so you can see a part at a time. Yeah, a uniform rod has the mass m and length 2a. A particle of mass 2m is attached to the rod at the point C where A to C is 1.5a. The rod rests with its end A on a rough horizontal ground. So right there, rough horizontal ground. Let's go and highlight stuff. Yeah, there. Okay, this is uniform. That's important. The length is 2a. The mass is m. Okay, A to C is 1.5. We'll look at that later. Right, rod is held in equilibrium and angle of theta to the ground by a light string that is attached to the end B of the rod. The string is perpendicular to the rod as shown in figure 2. There you go, that's your perpendicular thing there. Explain why the frictional force acting on the rod at A acts horizontally to the right on the diagram. Okay, so why the frictional force acting on the rod at A is going this way. Well, what's going to happen? You've got a rod on a ground, pressuring it that way, isn't it? Naturally, you're going to have friction working against you. It's a rough ground right there. Okay, that's the simple answer. Okay, so you could say something like the frictional force acts in an opposite direction that the rod will slide at A. And the reason is to, the frictional force, if it's in equilibrium, which it is, it's held in equilibrium, it will give you the force needed, so it remains in equilibrium. Okay, so the friction force will match it. That's question part 1. Right, anyway, so part 2, it says the tension in the string is T. Show that T is equal to 2mg cos theta. And then given that cos theta is equal to 3/5, show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg over 25. All right, let's go and tackle those together. Before we do that, guys, you need to annotate your diagram. Okay, make sure that your diagram is good. So let's start with that frictional force right there. So that's frictional force, we know. We also have a reaction force. Anytime you got something resting on the ground, so the rod is resting on the ground right there, it's going to create a reaction force going up. Okay, otherwise it will go into the ground. The ground will give an reaction force back. So that's R right there. And about the uniform, the rod is uniform, which means right in the center of the rod, halfway point of the rod, is your mass. Okay, your mass is M, so the weight is going to be mg. All right. Now we also told the length of the rod is 2a, so that means, from there to there is 2a. So the halfway point from there to there is just a. Okay, and obviously from there to there is also a. So let's write the first a down here. That's a. And what we told about c. C is at the point where a to c is 1.5. So a to c is 1.5. If this is a already, that's 0.5. So that means c is actually dividing this exactly in half. So that's going to be 0.5 right there, a, and 0.5 right there, a. Okay? Because a to c is 1.5a. All right? What else? Oh, okay. C is also going to have a particle there of mass 2m, so it's 2mg, the weight. What tension? The tension in the string. So this is the string, all right, which is holding this rod up. It's going to have a tension. Tension is going away from there up to whatever's holding it. Okay, the ceiling or something. So that's T, tension. All right, so that's my diagram done. With these questions, we start by taking moments. All right, so we need something that will introduce our T, okay, our tension, so because that's what we're trying to find. So you take moments by introducing this force into it. So it's not a good idea to take moments from B, because if you take moments from, because you can take moments from any of these points, all right? But if you take moments from B, what you're doing is eliminating T from your calculations. So you don't want to be doing that. So take it from a place where you can have T in your calculations. So you can have all the clockwise and the anti-clockwise stuff in your thing. Now, if I take it from here, it's actually good because first of all, I get T involved. And secondly, I don't need to know the frictional force here or the R because, you know, I'm taking a moment from there. That means these guys are not involved in my calculation. All right. So it's actually a good idea to take it from A. All right. So let's go ahead and do that. Before we do that, I need to take another drawing of this with me so I can look at it. Okay. So here's the drawing. I'm going to take moments from A. So moments from A. All right, so if I'm taking moments from here, I've got 1, 2 forces that are going around that. So it's going to be going clockwise. And T is going to be going anti-clockwise. Okay, so I am going to have mg times by, now mg times by the distance to this. Okay, so I need an expression for this. I need an expression for that distance right there. What is it? So if you imagine this triangle right there that I've drawn, I've got my angle right there. It's an adjacent side, so it's going to be using cos. Okay, the length of it is going to be A right there. Okay, so it's going to be A cos theta. Okay, that's that. That's the expression for that. So I can add it to this. So it's going to be A cos theta. That's one. Plus the other one, so 2mg. So once again, 2mg is my force and the perpendicular distance to my, where I'm taking my moment from. So I need an expression for this side. Okay, that's going to be 1.5a cos theta. So it's going to be 2mg times by 1.5 a cos theta. All right. Now I've done all my clockwise. Anti-clockwise is a t. So it's going to be t times what? Well, look, t and the distance to this is already perpendicular. Okay. So it's going to be t, the force, times by, well, this is 2a. Okay. So it's just going to be t times 2a. So if we go ahead now and just simplify things, so we get, hang on, we can actually divide by a here. Look, everything's gone a. In fact, no, before I divide by a, let me just tidy up so that you can see it properly. So mga cos theta plus 2 times 1.5. What's that? What's 2 times 1.5 is 3, yeah? So 3 mga cos theta is equal to 2at. So look, cancel out the a's here. That's gone. All right, so we have mg cos theta plus 3 mg cos theta is equal to 2t. Now, you're adding these cos thetas and with mg's, right? So 3 plus 1, that gives us 4 mg cos theta is equal to 2t. Divide by 2, you got t on its own. So therefore, divide 2 on the other side, you get 2 mg cos theta. And that's what it wanted you to find right here. Okay, given that cos theta is equal to 3 over 5, show that the magnitude of the vertical force exerted by the ground on the rod at A is 57 mg over 25. Okay, so what's going on here? Let's just make this smaller. So for part C, we are finding R. So if I make a small version of this diagram again, let's just paste it right there. What's going on here? Okay, let's see what's going on here. We want to now resolve this to find R. So to find what R is, so let me just go back there, yeah? The magnitude of the vertical force, okay, exerted by the ground on the rod. So this is finding what R is right there. We want to find that. So we're going to resolve. Okay, now to resolve, we can resolve like the R and the MGs. Can you see they're in one direction? The only one that isn't in a good direction is this. All right, so we need this one's this direction. Okay, so let me just get rid of that. So everything else is like this, yeah? It's all good. This is going down, this is going up, but this one, we need that. So we need this one, guys, yeah? So we're going to resolve. So to do that, we are going to draw a dotted line. And again, which way is the direction of the arrow is going to be? This way and going up, isn't it? Yeah? Now, a lot of you might be confused about the angles that come from this, okay? And this is where I've done some detailed explanation of this. So watch this carefully. That and that parallel, yeah? That angle there and that, so this angle right there is the same, isn't it? Okay, so let me just get rid of that. Look, there and there. So these two angles are alternate angles. We know that rule. What's the so if that is theta, what would you say about those two lines right there? They're 90 degrees, isn't it? Yeah? So this is 90 degrees, yeah? But this is also 90 degrees. Right there. So, wait, let me get rid of all that. So this is 90 degrees. You know this angle is theta. You can find out what this angle is by doing 90 minus the theta. Right? That's going to be 90 minus theta. So imagine this angle here is called 90 minus theta. Remember that. Let that go. So now, if you look at this, which is 90 degrees, what's this angle going to be? Well, that's going to be 90 degrees minus 90 minus theta. Let me write that down. It's going to be 90 degrees minus 90 minus theta. And what happens is you end up cancelling out those. The theta, the negative and negative becomes positive. So you end up with just theta. So inevitably, this angle becomes theta. All right. If you need to do this in an exam, you don't have to go through all the proofs. You can just go straight to saying that this is theta, as long as you remember. But I just tried to give you some of the proof here. Okay. So we're just going to get rid of this. Now, you've got this as theta. Everything else is ready now. Okay, you can now express this component. Okay, what's that going to be? That's going to be t, and that side is a adjacent. So it's going to be t cos theta. And remember, we've been given in the question cos theta. He gave it to us, given. Cos theta is equal to 3/5. So let's go ahead now and resolve up and down like this. So we're going to resolve like that. Okay, we're going to make this way equal to that way. Not that. Yeah, we're going to make this way equal to that way. So what do we have? We have R. Yeah, R is positive in that direction. This is also going to be in the direction of R. So let's introduce that to our calculations, guys. Yeah, so it's going to be plus, what do we have? T cos alpha, because this is, I said, T cos alpha. Okay, and now it's going to be the minuses, which is those. Okay, those are going to be negative because it's going in the opposite direction. So it's going to be minus mg minus 2mg. Okay, that's going to be equal to 0 because it's in equilibrium. Okay, so let's go ahead and now substitute our cos equals, what was it, 3/5. So it's going to be R plus 3/5 T minus, so minus mg minus another 2mg is going to be minus 3mg equal to 0. Okay, so that's it. We're ready now to put into the form that it wanted. So let's times by 5 first. You want to do that? Times by 5 or not? I mean, I'm just thinking about getting rid of this. Let me just see the final version. What do they want? Okay, so they want the R to be shown like this, yeah? Okay, so let's just times it by 5. All right, so let's times it by 5 first. So it's going to be 5R is plus 3T minus, so 3 times 5 is going to be 15 mg, and 0 is going to stay as 0. So now let's take 5R on its own. So it's going to be 15 mg minus 3T, and then we're going to have R is equal to 15 mg minus 3T over 5. And then we also have T. equals, what was t's value? 2mg cos theta. So we know theta was 3 over 5. So that's going to be t is equal to 6 over 5 mg, yeah? So therefore, R is going to be equal to 15 mg minus 3 times 6 over 5 mg all over 5. And that gives us 15 mg minus, what's that, 18 over 5? Mg over 5. Now, I want to get rid of that fraction right here. How do I do that? I multiply everything by 5. Yeah, everything by 5. Okay, what does that give me? 75 mg minus 18 mg all over 25. So 75 mg and 18 mg, that gives us 57 mg all over 25. And that's my final answer. Now, the last part of this question, the coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, show mu is equal to 8 over 19. All right, limiting equilibrium means that it's just about to move. It's at its last stage, okay, before it will actually start moving. So we can still consider all the forces are equal to 0, okay? So let's go ahead and do that. How many pages do we have? Okay, so if we start here for part D, we are trying to find what mu is. Now, the triangle that we were given for cos, we're going to need that. So cos is 3 over 5. That's what it was. So using Pythagorean triples is going to be 4. So therefore, sine theta is going to be 4 over 5. Right. So if we resolve, let's say going in this direction. So let's look at our diagram again. Where was it? There. Let's take this one. Okay. So if we resolve in this direction, what do we have? We have that one and we have this one working opposite. So we have friction here and we have that one in that direction. So let's go put it in. So that's going to be F of R minus T. And remember, this right there is going to be sine. This is the angle. Opposite is sine. Okay, it's going to be sine. So T sine theta is equal to 0. So let's set up an equation for F of R now. So that's going to be F of R, and let's take everything to the other side. Now remember T, we found the value of T earlier. It was 2 mg. So it's going to be 2 mg cos theta, and then we're going to times this by sine theta. All right, so let's put all the values in. So 2 mg, cos is 3 over 5, and sine was 4 over 5. And if we calculate all of that, we get F of R is equal to 24 over 25 mg. So that's F of R, okay? So using F of R is equal to mu times R, F of R is 24 over 25 mg. Mu, we were given, no, we weren't given that actually, so it's going to be unknown. The reaction force we found earlier, which is here, so that 57 mg over 25, so 57 mg over 25, we can work out what mu is by dividing onto the other side. So we're going to have 24 mg over 25 divided by 57 mg over 25 equaling to mu. Now when it comes to division, keep, flip, change. No, keep, change, flip. Okay, when it comes to division, keep, change, flip. So therefore we're going to have 24 mg over 25 times by 25 over 57 mg equals the mu. The 25s can cancel. We get 24 mg over 57 mg. So 24 mg over 57 mg equals 2 mu. 57. Okay, mg equal to mu. So I can now cancel out the m and the g here, and 24 over 57 is our value of mu. So 24 over 57, and that gives us 8 over 19. And that's your final answer. All right, question 5. A golf ball is at rest at the point A on the horizontal ground. The ball is hit and initially moves at an angle alpha to the ground. The ball first hits the ground at the point B, where A to B is 120 meters, as shown in the figure 3. The motion of the ball is modeled as that of a particle moving freely under gravity, whose initial speed is u meters per second. Using this model, show the following. All right, now what I'm going to do is I'm going to draw my own diagram down here to show this. So we're going to have u going like that, an angle of alpha, so that's u meters per second. And if we draw some components real quick, this way and that way, this is going to be u sine alpha, and this is going to be u cos alpha. Okay, that's that. So we know that this ball will travel like that and do the rest of the journey. So if I want to find, if I want to show that u squared sine alpha cos alpha is equal to 588, what do I do? Well, let's just resolve like this. Okay, so what do we have in that direction? We have u is equal to u sine alpha. We have a is equal to minus g because it's gravity. We have s is equal to 0 because what happens? Remember, it goes up and comes back to the same position again on the ground. Okay, so s is equal to 0, and we have t is equal to, let's do a capital T. Okay, so what formula would I use? S equals ut plus a half at squared. So that gives us 0 is equal to u, which is u sine alpha, times by the t, plus a half minus g, and then t squared. Now, we'll leave that here for now. Let's go ahead and resolve this way. So this way, we are going to use the d is equal to s times t formula. So the distance, if we go up, again, the distance from A to B is 120 meters. Go in that direction. So it's going to be 120 is equal to speed, again, in that direction, is going to be u cos alpha. So it's going to be u cos alpha times by t. Now, if we make t the subject, that's going to be 120 over u cos alpha. We're going to substitute that right there and right there. Okay, so therefore, we have 0 is equal to u sine alpha, bracket 120 over u cos alpha, close bracket, plus a half minus g times by 120 over u cos alpha squared. Let's go work that out. So here, see that and that cancels. So it's going to be 120 sine alpha over cos alpha, and it's going to be a minus overall here, so that's where the minus is. So it's going to be g over 2, and then we are going to do the bracket squared. So it's going to be 1,000, no, not 1,000, 14,400 all over u squared cos squared alpha. Now, what happens next? So we want to make it look like this. Let's go back up here and revisit this. So what can I do here? Let's go and tidy up a little bit. We need to be very careful about how we tidy this up. All right, so shall we multiply by the u squared cos squared alpha? We can also, look, can you see we can multiply this across as well? Okay, so let's go ahead and do that. So that's going to be 0 is equal to, so we're going to multiply by all of this. Okay, so 2u squared cos squared alpha. All right, so the 120 is going to be multiplied by the 2, so it's going to be 240 u squared, and then sine alpha cos squared alpha all over cos alpha. So all I've done here, multiplied this over there. There's loads of ways you can do this. Okay, this is not the only way. So if you've got a way, a vision of how you're going to do this, no problem. Go ahead and do that. All right. And then on this side, what's going to be left is just going to be 14,400 g. Okay, because all of that multiplied up there. Okay, gone. So now we can cancel out the cos here with one of those. So what do we have left? We've got 240 u squared sine alpha. You can, and that's going to be equal to 0. You can take the fact that g is actually equal to 9.8. All right. So if you do 14,400 times by 9.8, you get minus 141,120. Okay, so now the g is gone, disappeared. And on this side, this remains. And of course, you probably figured out what you're going to do next. You're going to take this onto the other side because you want a positive. So therefore, it's going to be 141,120 is equal to 240 u squared sine alpha cos alpha. And then we want to make, what do we want to make this subject? I forgot. 588. Okay, how do we get 588? We are going to divide by 240. So if we divide 141,120 by 240, we get u squared sine alpha cos alpha, and that gives us on that side the 588 is equal to u squared sine alpha cos alpha. And there you go. That's what it wanted. Right, I'm going to quickly do the next part. The ball reaches a maximum height of 10 meters above the ground. Show that u squared is equal to 1,960. So basically, what happens when something reaches the maximum height? Okay, v has to equal 0. Okay, and the maximum height is obviously 10 meters. So s is equal to 10. We got that sort of data from there. So let's go ahead and do that. So the maximum height is when v equals 0, s equals 10. What we're trying to find? I forgot. We're trying to find, it's a show question. So u, basically. So to show what u is. All right. So we can have u here as u sine alpha, and a is equal to minus g. So we're going up this way. All right. So we're going to use v squared is equal to u squared plus 2as. So it's going to be 0 squared is equal to u, which is u sine alpha squared plus 2 times acceleration, which is minus g, times by the 10. And can you see here, u is going to be the only unknown because g is obviously a value that we can use. So 0 is equal to u squared sine squared alpha minus 20g. And then we rearrange that to make u the subject. So we're going to have 20g is equal to u squared sine squared alpha. And we're going to make 20g divided by sine squared alpha is equal to u squared. Now, earlier on, part right there, part A, we had this. So look, can you see we can make an expression for u squared and sub it right there, all right? So we can say that u squared is equal to 588 over sine alpha cos alpha. And if we substitute that here, we can have, therefore, 20g over sine squared alpha is equal to 588 over sine alpha cos alpha. Now, if we remind ourselves what it is that we want to do, u squared is equal to 1960. Okay, so let's now multiply this by sine squared alpha, top and the bottom. So from there, it will disappear. Here, 1 will disappear and this will gain it. Okay, so you end up with 20g is equal to 588 sine alpha over cos alpha, which we know is tan. So that's tan. So therefore 20g is equal to 588 tan alpha. So alpha can be found by doing tan alpha is equal to 20g over 588. Now this gives us 1/3. So we are going to do tan alpha is equal to 1/3. We can use our triangle to get our answer for sine and cos if we need to now. So tan is opposite of adjacent, so 1/3, and therefore this one is going to be 1 squared plus 3 squared square rooted. That's going to be root 10. So that's going to be root 10. So therefore sine alpha is going to be 1 over root 10 or root 10 over 10, and cos alpha is going to be 3 over root 10. Okay, now what is u? Expression for u. We had an expression for u earlier right there. Okay, let's go ahead and use that. We can use either of those, yeah? Either of those. Okay, but we had that nice and simple one earlier. So therefore, u squared is equal to 20g over sine. Okay, sine is 1 over root 10 squared. Okay, and then if we square root that whole answer, we get 20g over 1 over root 10 squared. And then that will give us our final answer. Oh, actually, we wanted u squared, I think. Let's go back. Oh, okay. So we don't need to square root the answer at all. Okay, we don't need to do that at all. We can just work that out on our calculator. So 20 times 9.8 divided by 1 over root 10 squared. And that gives us u squared is equal to 1960. And there's your final answer. Now, in a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modeled as that of a particle whose initial speed is v meters per second. This refined model is used to calculate a value for v, state which is greater, u or v, given a reason for your answer. So you could say something like, if air resistance is used in the calculations, then the initial speed must be greater to travel the same distance of A to B, which was 120 meters. Okay, so v is greater than u. For part D, state one further refinement to the model that would make this model more realistic. You could talk about things like the dimensions of the ball. You could say model the ball as a particle, or use a more accurate value for gravity. Okay, so any of these will make the model more realistic. Hope you enjoyed this lesson, guys. Don't forget to give this video a thumbs up, and please share the channel and subscribe if you already haven't done so. Bye for now.